So today we're going to cover Chapter 7, Section 3. Today we're going to learn how to prove that a quadrilateral is a parallelogram. Now what you're going to see today is all of the theorems that we learned yesterday. Today we're going to flip them around and we're going to turn them into converses. So we're going to switch the if and the then. And these will be our ways of proving that the quadrilateral is a parallelogram. The first one is called the parallelogram opposite sides converse. Again, don't memorize the number. This is our first way of proving that a quadrilateral is a parallelogram. So what this states is if both pairs of opposite sides of a quadrilateral are congruent, then the quadrilateral is a parallelogram. So we need both pairs to be marked as congruent. So the statement I can make from this picture that's drawn here is if AB is congruent to CD and if BC is congruent to DA, then we can state that ABCD is a parallelogram. The second way that we can prove that a quadrilateral is a parallelogram is by using the parallelogram opposite angles converse. So if both pairs of opposite angles of a quadrilateral are congruent, then the quadrilateral is a parallelogram. And I can make a similar statement based off of this picture. I would state that if angle A is congruent to angle C and angle B is congruent to angle D, then ABCD is a parallelogram. Notice the diagonals weren't drawn in, so I was able to name the congruent angle pairs with just one letter. If the diagonals were also drawn into this picture, I would have needed to name these angles with 3 letters. The third way of proving a quadrilateral is a parallelogram, and this one's new, is by showing that one pair of opposite sides of a quadrilateral are both congruent and parallel. Then the quadrilateral is a parallelogram. This is called the opposite sides parallel and congruent theorem. This is new. It's not a converse. So notice in the picture, on one pair of sides, the BC and the AD side, it's got both a congruent mark and a parallel mark. So the statement I can make is if BC is parallel to AD and BC is also congruent to AD, then ABCD is a parallelogram. So let's say instead the picture looked like this. A, B, C, D. And let's say the parallel marks were on BC, but the congruency mark was on AB and CD. If you're given a picture like this, this is not enough information. The parallel and the congruent mark needs to be on the same side. So this is not enough information to show that this is a parallelogram. You would need more information. So this is a fail, not enough. And in order to use this theorem, the congruency mark and the parallel have to be on the same pair. You can't have a marking on one pair and then the other marking on the other. It has to be on the same pair. So if it's on 2 separate pairs, it's not enough information. It potentially could be a parallelogram, but with just that pieces of given, it's not enough information. Okay, now our fourth way is our parallelogram diagonals converse. So if the diagonals of a quadrilateral bisect each other, then the quadrilateral is a parallelogram. I'm going to add a little E here in the picture so I can make my statement. So I could state that if BD and AC bisect each other, then ABCD is a parallelogram. That's one statement I could make based on the picture. Another statement I could say is if BE, because I added in that point E there, is congruent to ED, and AE congruent to EC, then ABCD is a parallelogram. So there are 5 ways to prove a quadrilateral is a parallelogram. We just talked about 4 of them, but the 5th way is the definition. It's number 1 here, just to show that both pairs of opposite sides are parallel. This is the definition of a parallelogram. Number 2, show both pairs of opposite sides are congruent. This is my parallelogram, opposite sides, converse. Show one pair of sides is parallel and congruent. This is our new theorem. This was the opposite sides, parallel and congruent theorem. Number 4, show both pairs of opposite angles are congruent. This is my parallelogram, opposite angles, converse. And then the last one, show that the diagonals bisect each other, and that's the parallelogram, diagonals converse. So number 1 was what we learned yesterday, the definition. 2 through 5 here are what we talked about today. The 3 new converses and then the new theorem. The next slide has exactly the same thing. However, it's giving a picture of a parallelogram with either the congruencies on the sides or the angles or the parallel lines marked. So the next slide has pictures demonstrating the 5 ways. So the first way again is the definition. Notice both pairs have parallel arrows on them. The second one, again, you're not memorizing the numbers here. You can memorize the name or what it states. So when you show both pairs of opposite sides are congruent, remember that's the parallelogram, opposite sides, converse. When you show both pairs of opposite angles congruent, again, parallel, opposite angles, converse. And when you show one pair of opposite sides are congruent and parallel, that's the new theorem. So opposite sides, parallel, and congruent theorem. And then the last one is the parallelogram, diagonals, converse. So the next slide, it wants us to state the principal definition or theorem that enables us to deduce from the given information that this quadrilateral down here is a parallelogram. So for number 1, it's giving us that BE, and I'm going to add in, instead of an equal sign, I'm going to add a congruency mark. So BE congruent to ED and CE congruent to EA. So I'm going to add in those markings to the picture so I can see what it's talking about. So BE is here, ED here. CE here, and EA. Notice these are our diagonals. And notice by adding in those congruency marks, I can see that those diagonals were bisected. So this is the parallelogram, diagonals converse. And remember what this states is that if diagonals of a quadrilateral bisect each other, then the quadrilateral is a parallelogram. For the next one, we have angle BAD, which is here, congruent to angle DCB, and then angle ADC, congruent to CBA. Notice these are opposite angles in my quadrilateral. So to show that ABCD would be a parallelogram, I'm going to use the parallelogram, opposite angles, converse. Because I've just shown that both pairs of opposite angles are congruent. For the next part, they're telling me that BC is parallel to AD and that AB is parallel to DC. When I have both pairs of opposite sides parallel, this tells me it's a parallelogram by using the definition. So this is I would be using the definition of a parallelogram for number 3. For number 4, I'm going to add in a congruency symbol between the letters. So BC congruent to AD and AB congruent to DC. Let me go ahead and add those markings to my picture. So BC congruent to AD and AB congruent to DC. This one, number 4, is using the parallelogram, opposite sides converse. And then for the last one, notice it's telling me that BC is parallel to AD and BC is also congruent to AD. Notice it's already marked here. So since they have the same marking on both sides, I can use my opposite sides, parallel, and congruent theorem. And these are your 5 ways of showing that a quadrilateral is a parallelogram. When you're writing your proof, you don't need to use all 5. Depending on your given, you're only going to use one, but you're going to need to get the statement for the congruencies or the parallel into your statements, but your reason will be one of these 5. All right, next slide. For what values of x and y is quadrilateral PQRS a parallelogram? Well, what I can use is my parallelogram opposite sides converse, and I can show that to find x, I'm going to set PQ equal to SR. So I'm going to be using my parallelogram opposite sides converse. So I'm going to be setting SR equal to PQ, because when opposite sides are congruent, then we can show that the quadrilateral is a parallelogram. So SR is 2x minus 1, PQ is x plus 9. This is what I'm going to be using to find x. I'm Subtract x. X minus 1 equals 9. Going to add 1. And x equals 10. Now notice the question only asked me to find the value of x and y. However, let's say instead they said find the value of PQ or SR. Remember, PQ was x plus 9. SR was 2x minus 1. It wouldn't matter which one I plug it in. They both need to give me the same answer. If they don't, I've done something wrong. So they both have a value, the length of 19. Now, to find y, I am going to set PS equal to QR. So to find y, I'm going to be setting PS equal to QR. PS is y, QR is x plus 7. Now, you're going to say, oh no, I've got two different variables. But if you remember, we just found x. So I'm going to use that value and plug in a 10 for x. And y equals 17. Same thing here. If they had asked me to find PS, well, PS equals y, so PS just equals 17. If they had asked for QR, QR equaled x plus 7, so again, 10 plus 7, and QR also equals 17. Again, they both need to end up giving us the same answer. But the final answer to this question were just the values of x and y. So just be careful when you're answering questions on the quiz to read what specifically it's asking for. The next one is asking us still to find x and y, but this time they're giving us angle measures. For example 3, it wants us to find the values of x and y that would make this quadrilateral a parallelogram. So what I'm going to do is use my parallelogram, opposite angles, converse. And as long as this angle A is congruent to C and D congruent to B, then this is a parallelogram. So I'm going to first find x. So to find x, I'm going to be setting angle C equal to angle A. Doesn't matter how you set it, equal to each other. So C is 2x. A is 3x minus 32. I'm going to get my x's together by subtracting 3x. I get negative 1x equals negative 32. Divide by negative 1, and x equals 32. Now, if it asks for, find the measure of angle C. Angle C was 2x, so 2 times 32, and you get 64. So angle C is 64 degrees. If they would have asked for angle A, it's going to give us the same number, 3x minus 32. 3 times 32 minus 32, 96 minus 32, and I get 64 again. So angle A also equals 64 degrees. Now let's find y. Again, I'm using the same theorem. So to find y, I'm going to be setting, this time, I'm going to set angle B equal to angle D, the opposite angles. Angle B is 4y. Angle D is y plus 87. I'm going to subtract y from both sides. I get 3y equals 87. I need to divide both sides by 3. And y equals 29. Now this is what it had asked for, just to find x and y. But again, if they want us to go back and find any of the angle measures, angle B was 4y. So 4 times 29, and that gives me angle B equals 116. And then angle D was y plus 87. So 29 plus 87, and I get exactly the same thing, 116. Next slide, proof. It says write a 2-column proof given that angle ADB is congruent to CBD and ABD is congruent to CDB. Prove that ABCD is a parallelogram. So let's get this set up. Statements and our reasons. Number 1, state all of this given. ADB, congruent, CBD, and ADB, or ABD, is congruent to angle CDB. And this is given. Notice the picture is marked for me already. So I need to figure out how I can use one of the 5 things we just learned about to show that this is a parallelogram. So notice I don't have opposite angles congruent, but I got these little pieces here. So I've got this angle here, congruent here, and then these right here. And if you remember, if we have AD parallel to BC, and then if DB is my transversal, these are alternate interior angle pairs. I could also show the parallel this way, which would create, so the parallel this way would be these two, and then I'll do the same markings that are there, and then these. So because I've got congruent alternate interior angles, I can use my alternate interior angles converse to prove that AB is parallel to CD and that AD is parallel to CB, and my reason is the alternate interior angles converse. Remember, the converse of all these special angle pairs proved that the lines were parallel. So now that I can add in parallel marks to my sides, I've got 2 pairs of opposite sides that are parallel, which is the definition. So now I can state what I was trying to prove, that ABCD is a parallelogram, and the reason is the definition of a parallelogram. All right, last example. Given that AB is parallel to DC and AB is also congruent to DC, I want you to prove that AD is congruent to BC. So let me go ahead and draw the parallelogram now. So A, B, C, D. I'm going to label my given. So AB is congruent to DC and parallel. Remember, this is one of the ways to show that a quadrilateral is a parallelogram. However, this time, I'm not asking you to prove it is a parallelogram. I'm asking you to show me that AD is congruent to BC. But if you think about it, once you show that something's a parallelogram, then you can bring in the theorems that we learned yesterday. So let's state the given. AB parallel to DC and AB congruent to DC, and that's given. Then for number 2, I'm going to state that ABCD is a parallelogram. And that reason is the opposite sides parallel and congruent theorem. So now that I've established that my quadrilateral is a parallelogram, now I can go back and say that these opposite sides, AD, is congruent to BC, and that reason would be the parallelogram opposite sides theorem. So this was what we learned yesterday. So now I can go back and say any of those theorems that we learned yesterday can apply to this quadrilateral. So parallelogram, opposite sides theorem. And that is it for the notes on 7.3. Now, if you forget any of these names, you can also restate the theorem in the reason column. You don't have to use the name. So if you forgot the name, you could have also said, if a quadrilateral is a parallelogram, then opposite sides are congruent.